Hello, welcome back. I'm going to continue in this lecture with the example that we have been working with in the past two lectures. So again, you have this example on the slide. You should be familiar with this example by now. In the previous lecture, I showed you how you calculate a standardized test statistic from the sample data. And for our example, we calculated the test statistic as minus 2.03. And then we also, then we compared that to our critical Z value, the negative Z 0.05 as minus 1.645. And because our standardized test statistic is less than our critical value, it falls within the rejection region. And therefore, we reject the null hypothesis in favor of the alternative, and we came to a conclusion. So in this lecture, I'm going to continue with this example, and we are going to look at a different approach to decide whether to reject or not reject the alternative hypothesis. And you will see how these two approaches are actually the same thing. And this approach is called the p-value method. So I have here on the slide a summary of our example. I have the null and the alternative hypothesis, then also the calculated test statistic value calculated from the sample information, minus 2.03. And then I have my critical value of minus 1.645. Okay, so on this slide, I have a summary of our example. I have the null and the alternative hypothesis. And then I have the calculated test statistic value. We calculated it from the sample information, negative 2.03. And then we have our critical value, minus 1.645. And we said because our calculated value is less than our critical value, we reject the null hypothesis. So if I make a drawing of my normal distribution, my critical value is minus 1.645. And we know that the area to the left of this critical value is 0.05. Now, if we take the calculated test statistic value, which is minus 2.03, and we take the area to the left of this test statistic, that would be that red area. And if you have to compare the red area with the blue area, it's very obvious that that area must be less than 0.05. And by implication, if the area to the left of my test statistic value, if it is less than my alpha, my level of significance, then it falls within the rejection region, and therefore we will reject the null hypothesis. So we can actually go and calculate that red area. If you go and calculate that using your Z tables or any software to find that probability, you will get that the area to the left of negative 2.03 is 0.0212. So that is less than alpha, my level of significance. And as I said, by implication, that means that it falls within the rejection region, and we will reject the null hypothesis. Here I also have it on the slide. It's just the same thing. The area to the left of my critical value, minus 1.645, the blue area is 0.05. And the area to the left of my test statistic, negative 2.03, is 0.0212. That's less than 0.05. And that means that it lies to the left of my critical value. It falls within the rejection region. And this is because I'm working with the area to the left of my test statistic value because our alternative hypothesis was left-sided. Now that area to the left of my observed test statistic value, that area is called my p-value. Now, a formal definition for the p-value is that the p-value of a test is the probability to get a test statistic at least as extreme as the calculated value if we assume that the null hypothesis is true. So if my p-value is small, it means that there's a small probability, a small chance to get a test statistic value at least as extreme, in this case, at least as small as the one that we have calculated if the null hypothesis is true. Now, we reject the null hypothesis if the p-value is less than alpha, our level of significance. Now we can do the same thing if we are working with a right-sided alternative. So if you look here, if our alternative is right-sided, let's look at our let's look at the graph on the left-hand side. So my critical value is 1.645. So the blue area is 0.05. If my test statistic lies to the right of 1.645, then the p-value will be that red area, and the p-value is then less than 0.05. By implication, my test statistic falls in the rejection region, and therefore we will reject the null hypothesis. If you look at the graph on the right-hand side, suppose my z test statistic value lies in the acceptance region, or it lies to the left of my critical value, then the p-value will be the area to the right of my test statistic. That area is more than the area to the right of my critical value, 0.05, and therefore we will not reject the null hypothesis. And then lastly, if our alternative hypothesis is two-sided, let's just look at the graph on the left-hand side. Suppose that my test statistic value is positive, then to get my p-value, I will take the area to the right of my test statistic and then multiply it by 2 to get my p-value. Or else, if my test statistic value is negative, to get my p-value, I will take the area to the left of my test statistic and then multiply it by 2. That will give me my p-value. Again, if my p-value is smaller than my level of significance, 0.05, it means that my test statistic value falls within the rejection region, and therefore we reject the null hypothesis. But if you look at the right-hand sided graph, if my test statistic value does not fall within the rejection region, then my p-value will be the red shaded area. That will be more than my alpha, my level of significance, and therefore I will not reject my null hypothesis. You would have noticed in the previous slides I worked with Z 0.05, which is 1.645. In this slide I work with Z 0.05 divided by 2, which is Z 0.025, and that is equal to 1.96. The reason for that is because we are working with a two-sided alternative, then this blue area here is 0.025. This area here is 0.025. If we add them up, then that should give us the 0.05. So because we are working two-sided, we take the area to the left and to the right, and they have to add up to 0.05. Okay, so we can conclude with this slide. If the p-value is less than 0.01, we say there's overwhelming evidence in favor of the alternative hypothesis, and the test results is highly significant. If the p-value lies between 1 and 5%, we say there's strong evidence in favor of the alternative, and the test result is significant. If the p-value lies between 5 and 10%, we say there's weak evidence in favor of the alternative. And if the p-value is greater than 10%, we say that the result is not statistically significant. In other words, we do not reject the null hypothesis.